April the 27th, 2005, Toulouse, southwestern France. 6 test pilots are about to fly a massive aeroplane into the record books.
Le numéro de paramètre c'est 27, papa.
Tu es toujours. Tu es toujours.
Among the thousands here to witness the event are many who've helped to build the giant new machine.
This is what it's all about. Whether you're an aviation or an engineering enthusiast or not, this is still a very significant day.
Today is the big day for us. Now everything will pay off, in terms of sweat, in terms of time, in terms of problems we had in the past, and now today everything is reset to zero, and we look forward to see this baby fly.
It's taken over 10 years and £6 billion to get to this moment. The maiden flight of the Airbus A380, the biggest airliner ever built.
C'est 100% partout. C'est bon.
The world is addicted to air travel, and it's not hard to see why. Decades of fierce competition has resulted in ever more efficient aircraft, and flying has never been cheaper or more accessible. But there is one plane that, since it flew back in 1969, has not been superseded, and it's called the Jumbo Jet. The 747 has survived because in all that time, it's never had any direct competition. No one has ever had the nerve or the money needed to take on this aircraft with an all-new design. Until now. European plane maker Airbus is staking everything on a machine that they hope will replace the big Boeing and dominate the market for years to come. By any standards, taking on the 747 is a massive gamble. If they succeed, they'll make a fortune. If they fail, billions will have been thrown away.
This aircraft cannot be a failure. When you invest $10.7 billion on building what we're pronouncing to be the flagship of the 21st century, you can't fail. There isn't, well, we almost got there, or it's so-so, not too shabby. No, either it's going to be that flagship of the 21st century, or it's going to be a disaster.
Since 2003, Channel 4 have had exclusive inside access to this huge project. From the senior management fighting deadlines and budgets.
The people are exhausted already. They are under the highest pressure you can imagine.
To the men and women actually building the plane.
These moments really piss me off.
It's a tale of the struggle to manufacture giant components all over Europe, and then to ship them to France for final assembly.
We are crazy.
It's a mammoth high-technology engineering challenge. The race to build, test, and fly the brand new machine. In charge of it all is 48-year-old Charles Champion, head of the entire project. He understands only too well the risks involved.
Well, what is at stake, I would say, with such a program is basically the future of the company, as such.
Really?
Really.
Airbus was created in the 1960s, when Spain, Britain, France and Germany decided to take on the might of the American aviation industry. Their first aircraft took off in 1972, and nowadays they make over 300 planes a year. But the A380 is on a different scale altogether.
Building such an aircraft, it's a bit like climbing a mountain. Yeah? You see the mountain in the distance. It looks, high, but not too high. And you start walking, and you got the first level, and then you say, "Whew, this one was hard." And you got the next one. It's even harder. And so you see the summit. It's getting closer, but at the end of the day, there's still a lot to walk and a lot to climb.
The project began 17 years ago. Philippe Jarry was involved from the start.
I think it was in '88, where there were the first meetings, very secret meetings, between very few people in Airbus, who said, well, if we had to imagine a very big airplane, let's say 500 or 600 seats, how would it look?
At the time, the biggest Airbus was a 380-seat A340. Could this plane be modified to keep the cost down?
The first ideas was to use existing components, which has been an Airbus tradition. And so the people started, for example, assembling two A340 fuselages side by side and make it a kind of horizontal fuselage cross-section. Put big wings, of course, and maybe a kind of V-tail, and that was really the first sketch.
Called the ultra-high capacity aircraft, this unusual concept was rejected on safety grounds. It would take too long to evacuate in an emergency.
The main problem that the people were facing was a very, very large number of seats installed abreast. And it was difficult to accommodate enough doors on each side to ensure for the evacuation.
The next idea combined the A340 with a smaller plane, the A320, giving a cross-section similar to the front of a 747, but running full length. But that wouldn't have the capacity required.
If you pretend to offer to the airlines, the major airlines of the world, a top-class, top-efficient airplane, you cannot compromise. As simple as this. So it has to be a fully new design.
Starting from scratch is the most expensive option, but it's what Airbus decided to do. The plane went through dozens of iterations as designers and engineers worked for over 10 years. The size was driven by the airlines, struggling to increase passenger numbers in the face of increasing air traffic congestion.
The airlines told us, don't be shy, don't hesitate. Of course it has to be big. It has to be bigger than anything that is flying. So don't be shy, don't hesitate. Make it really big.
The resulting design was a plane with 49% more space than a 747, capable of carrying over 850 passengers. Using advanced technology, it would be highly efficient and, crucially like the Jumbo, have no competitors. If they could get it right, the A380 could fulfill its ultimate goal: to make huge amounts of money.
Is this about money? Of course it is. Think about the revenue potential. Each airplane sells in today's dollars at a catalog price of about $300 million. Now, over 20 years, our global market forecast is about 1,600 aircraft. Now, assuming we got that entire market, we won't, but assuming we did, with a monopoly position, you'll get pretty close to it, that would be, over the next 20 years, $480 billion US dollars. Suppose you only get half of it, $240 billion US dollars at catalog price. Now that is an awful lot of money.
With potentially twice the GDP of Switzerland at stake, the challenge now is to build it. December of the year 2000. And now that Airbus have a basic design for their huge new plane, they can start building it, or rather the buildings that will build it. The aircraft is so big that new factories are needed for almost every major component. On top of that, Airbus always share the work between its 4 founding countries, so a major international construction project is required. The A380 will be built from a giant kit of parts made mainly in Spain, France, the UK and Germany. And each country has had to invest heavily in new facilities. Other parts will come from more than a dozen other countries, so the plane is truly a global effort.
It's big, it's really big. You name it and the people are working on it, so at the end of the day it's almost impossible to count the number of people working on this project.
The biggest single development is near Airbus headquarters in Toulouse. The final assembly line is where the various components of the plane will be joined together. Work began in 2001 on a complex that would cost £240 million on its own. A third of a mile long, it covers 24 acres, big enough to hold 8 planes at once. The huge cost of this programme means Airbus have to sell 250 planes just to break even. And to help the drive for early sales is a nearby showroom. Inside is a full-size demonstrator of the new machine. Getting customers to spend a lot of money on a plane that has yet to fly is quite a challenge. But Chief Commercial Officer John Leahy is full of confidence.
Why would you want to spend $265 million for something like this? Because it'll do something no other airplane in the world can do. And that's bring people 8,000 nautical miles in a level of comfort that's never been provided before.
Although this interior is just a fantasy, an exercise in design possibilities, it is still a salesman's dream.
How often do you see this? Well, yes, it's an extra large loo, but it's also a shower. And this is something that you don't see in an airplane, and maybe you should.
The mock-up is designed to whet the appetite of customers such as Sir Richard Branson, head of Virgin Atlantic. He's agreed to buy 6 planes, based on the promise that the A380 will set new standards for performance and efficiency.
There are a lot of challenges when you're building a brand new aeroplane, but Airbus are a very, very professional company, and we would not be buying planes from Airbus if we didn't feel that we could trust them to deliver.
The plan is to build 4 prototype aircraft and then move seamlessly into full-scale production. If all goes to schedule, the aircraft should be in service by 2006. The first piece of metal is cut in January 2002, and shortly afterwards, huge components are being produced in the brand new factories all over Europe. In Germany, large sections of the fuselage rapidly take shape, put together using high-tech materials and thousands of rivets. In France, the carbon fibre centre wing box, the structural heart of the aircraft, comes together. In the UK, in Broughton, North Wales, the wings themselves are assembled. Built up from hundreds of components, each one is constructed standing on its rear edge. It looks more like the hull of a ship than part of a plane. By November 2003, the first wing is ready to be hoisted out of its supporting jig, and engineer Simon Shingler and his team will get their first sight of the giant part.
The whole idea of having you all here is to make sure that you're all concentrating on your one specific station, right? And that's how we're going to ensure that we're going to take this wing out without anyone hurting themselves or without the components getting damaged. When we're lifting this wing out, make sure all the mobile phones are turned off. Right.
Despite the laughter, this is a serious business. The wing weighs over 30 tons, and to damage it now would be disastrous.
Everybody gets very excited, and it's easy to sort of leave one of the attachments in place or part of the tooling because there's so many attachments around the periphery of the wing. If that happens, then it causes damage when it's being lifted.
Alan Ferguson is in charge of the first stage, attaching the hoist to the solid titanium lifting points.
What we're doing is we're making sure we get the crane correctly aligned with the lifting attachment, so as when we make the initial lift, we don't get any sway on the wing. So it's critical, yeah.
That's going to be twisted back on like
Right, we're ready to go. We want everyone in place now, and then it's like we're going for it now completely.
Right, gather round please, gents. The operations team and the crane driver is going to take some weight. We're going to release the front spar, and then we're going to remove the wing.
Try to stay calm, don't panic. We'll do everything nice and slowly, there's no rush now, but once we start, we're not stopping. Thanks very much. Okay. Right. Steady now. Okay. All right, you're clear, take it off. Right. Get that spar support out, please. Is it down? Right. Yeah.
With one small movement, the wing is free.
Clear. I think the wingtip's clear. Yeah.
Now it can be lifted out and into the next hall.
Don't forget the outboard end.
The wing may look big now, but once the rest of the parts are fitted, it will grow by half as much again. The true size of the A380 is starting to show.
I think the whole world's going to look on in awe the day it flies. I think the Boeing Aircraft Company have got something to be very wary of.
But even while the major components are being built, detailed design of the interior and many other parts is far from finished. Charles Champion and his team of senior executives meet once a fortnight in Toulouse to try and keep the project on course. With so much happening at once, there is a real danger of becoming overloaded.
Can we start? It's a question of time management, because not only time management at work, but also time management with your personal life. And you can burn out. Basically, if you're not careful, you just can burn out, and at the end of the day, you're out.
Andreas Fähring has been brought in to replace the previous head of interior engineering. For him, it's particularly tough because he's taking over a department that is already 3 months behind schedule and over budget.
Team and myself, we are under enormous pressure because we have to keep the timeline and we are late. We have to keep the budget line and we have major difficulties to do so.
Even at this stage, Andreas and his staff are suffering from the punishing schedule.
People are exhausted already. And sometimes they are a little bit, let's say, overstressed, and the reaction is overstressed as well. Because if you then have a very, very quick requirement coming in, you have to do this, you have to speed up, and so on. They do not understand because they are working like hell already.
Andreas and his team work from this unmarked warehouse near Hamburg in Germany. In private, this is where Airbus and the airlines can agree exactly on the interior design of the plane. Each airline wants a customised interior, so Andreas has to engineer dozens of unique features to keep them all happy.
You can change the lighting area over here. You can have green light, you can have blue light.
Then there's the task of turning the sales department's dreams in the mock-up in Toulouse of showers and the like into reality.
We will have showers on our aircraft, but not in a way like they are displayed at the moment in Toulouse, because these are sorts of designers, not of engineers building the stuff.
Even engineering something as simple as the overhead lockers is a challenge.
Which is manually operated. The loading limitation of these bins are 50 kilos or 60 kilos. So you can imagine that if you have a stewardess or a passenger trying to move 50 kilo like this, they are not that strong, and it is a difficulty.
Although the cabin doesn't need to be finished for the first flight, building and testing it is a process that will take several years. Even now, if the early customers are to get their planes on time, the team have their work cut out.
What is really needed is time. Time.
By March 2004, the first set of wings are nearing completion in Broughton. The fuselage parts are almost ready to leave northern France and Germany for the final assembly line in Toulouse, where everything will be joined together. Carrying such large objects thousands of miles is a major task in itself and requires one of the most complicated and expensive transportation systems ever devised. The parts will travel by road, river and the sea in a logistical dance that has to fit together perfectly and work first time. The fuselage, wings and tailplanes will be carried by ship from the factories in Germany, Britain, France and Spain, converging on the port of Pauillac near Bordeaux on the west coast of France. From there they'll be loaded onto barges that will carry them 59 miles up the River Garonne. But still the journey isn't over. A fleet of lorries will haul the parts by road the last 152 miles to the brand new factory in Toulouse. It's a highly complex scheme that's never been attempted before, and it starts in Hamburg on the 24th of March 2004 as the first finished fuselage sections of the giant airliner emerge into the light of day. The parts are carried on purpose-built radio-controlled, self-powered low loaders. Each one has 96 wheels and can travel at a maximum speed of 6 miles per hour. The factory is just a few hundred yards from the purpose-built dock where the cargo ship waits. Now begins a 970-mile voyage through some of the busiest shipping lanes in the world to the west coast of France. Thankfully, the weather is perfect. In Britain, a few days later, the Wings begin their journey. For the UK team, it's a significant day.
After the last 2 months of preparation, the previous 2 years of planning, we've actually got the moment now when the Wing's going. So it's an exciting time, and it's what people here have looked for many, many months.
Stage 1 of this 1,000-mile trip is to use another low loader to carry the Wing a mile from the factory to the nearby River Dee, where a barge is waiting. On the way is a narrow bridge, and there'll be just inches to spare.
Very close.
With the first obstacle behind them, the Wing is ready to be loaded onto the barge. Now the dangerous tides on this treacherous stretch of river are the next hurdle to overcome.
It's not to be messed with, this river.
The tide's important because downstream there are 3 low bridges, and beyond them lie constantly shifting sandbanks. sail when the tide is too high and the barge will hit the bridge. Wait for it to fall and they could easily run aground.
There's a real balancing act as to where you get off the blocks and get under the bridge.
Graham Harwood, the barge captain, has been studying the river for the last 4 months. He's hoping to clear the first and lowest bridge by just 50 centimetres.
The first bit is the bridges, having a clearance of probably around about 1/2 metre. You know, that's what we've set in. We've got to have 1/2 metre clearance under the bridges, so the timing is of the essence, like, you know.
At this time of the month, the current is running dangerously fast.
They haven't picked the right time for us because the tide is making probably about 5 knots. And, you know, we've got to compete with that later on. So not the best time of year, not the best tide for the first time it's been done, but I'm sure we'll manage it. We'll have to.
The wing is gently manoeuvred onto the barge and the low loader carefully retracted. It's time to put all the theory into practice. The crew are constantly monitoring the clearance under the bridge, but as they approach, they realise the strong wind is holding the tide back. They might hit the bridge too soon, so Graham holds off for a few more seconds.
Yeah, there it is. Okay.
Just hope it's ringing any taller than they say it is.
Look now. Hey, I tell you what.
That is nice. That is beautiful. Isn't that beautiful? Exactly 50 centimetres. Exactly.
Graham has judged it perfectly. Cutting it fine under the bridges has given him plenty of water under his keel for the remaining 13 miles of river. Soon he'll rendezvous with the ship that will take the wings to France. As the race to build the Airbus A380 gets underway, development continues all over the world. In Phoenix, Arizona, the aircraft's 16 escape slides are being made. Each one is custom built to meet stringent regulations, and that means a lot of testing. Each slide is designed on computer, and this is one of the most complex on the whole plane, the over-wing slide. Today it will be tested for real, a critical time for the engineers.
This is a brand new slide. It's fresh out of our prototype department, and it's never been deployed, it's never been slid on, and the pressure is on.
The slide fits in a small pack, which is mounted to a full-size mock-up of the plane. It allows passengers to get from a door here, across the wing to the ground, deploying almost as if by magic from here.
3, 2, 1!
The regulations say that 850 passengers must be able to get out of the A380 in just 90 seconds. And the only way to prove the slide is up to the job is to use real human beings. 40 people will take part in the test, and the first step is to get everybody warmed up.
Everybody does it! Let's go! Let's do it! Come on!
Ted Oney, who'll be running the test, is wearing a rather special shirt.
This is my lucky Hawaiian shirt, of course. Every time I want to run an evac, I wear this shirt, so when people in the plant see me in this shirt, they know we're running an evacuation test.
The aim of the test is to show the slide can hold up to the weight of the evacuees and allow a safe but speedy exit in an emergency.
our slide will have to have 40 people traverse down the slide in less than 17 seconds. That meets a rate, that meets our specified rate. So in the grand scheme of things, we'll be able to say that we could evacuate the entire airplane within 90 seconds.
Sliding can be dangerous, and part of Ted's job is to make sure nobody gets hurt.
You're evacuating an aircraft, you need to do it quickly, but I want you to do it safely because your safety is high on my concern list, okay? Remember, getting out of that aircraft, it's in a hurry. All right, we're gonna start in a minute, so put on your helmets, strap them down, let's rock and roll.
Stop shaking these stairs.
We've gone through literally a year and a half worth of development tests to get to this point. If it doesn't work today, then we've got to go back and redesign the slide. This is what it's all about today.
Okay, countdown. 3, 2, 1, go. Come on, guys. Out the door. Come on, come on, come on, come on, come on. Go. Go. Go.
Although some of the volunteers stumble, nobody gets hurt.
Oh, wow.
17 seconds.
That was great. It's always good to get the first one.
It was pretty good, you know. Somebody fell right in front of me. I had to jump over them. They were just too close.
In these tests, the passenger's weight is the main consideration, so the engineers are allowed to use able-bodied volunteers. It's a good thing, because 2 hours of solid sliding are needed to prove the design.
You got some bounce on that one. You okay?
At the very end comes the most dangerous test of all. To simulate an evacuation in a rainstorm, the slide is sprayed with water. It's risky because now everything is much more slippery.
As the water puddles on the floor at the toe end of the slide here, it means the landing surface is slick. People are used to landing normally, and suddenly it's much more slippery, and if we don't do our job right, we get a pile of bodies at the bottom.
Go, 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 go! Get out, get out, get out, get out, get out, get out, go, 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 go! Come on, come on, come on, come on! Yeah! All right! All right, yeah! All right, have a seat, have a seat. Great job, everybody, great job!
I'm not doing that no more. No way. I quit.
Excellent, excellent evacuation.
I'm very pleased. Yes, I'm happy with that. There wasn't a lot of bumping. The slide did well.
One slide tested, just 15 more to go. By the 7th of April 2004, thanks to careful planning and good weather, 3 huge pieces of fuselage are nearly at the factory where they'll be joined together. All the components made it safely to Pauillac, up the River Garonne and past the city of Bordeaux. Now comes the last leg, 152 miles by road to Toulouse. Loaded onto specially built trailers, the parts have spent the last 2 nights crawling through the French countryside, on roads closed off by the police. Although the end seems in sight, the biggest challenge lies ahead. 2 miles away lies the small village of Levignac. This is the narrowest point on the entire journey. According to calculations, the fuselage will only just squeeze past the houses with centimetres to spare. The event has attracted massive public interest, and the police are taking crowd control very seriously. Daniel Boutonnet is the man who has to keep this huge show on the road.
I'm confident. I'm not anxious, but for me, I would prefer to be 3 hours in the future.
If the calculations are wrong, the consequences are unthinkable. As they enter Levignac, the police are worried and progress is painfully slow. Now the moment of truth. Will the 7-metre wide fuselage fit through the gap?
This is the narrowest espace for the streets for all crossing Levignac. Yes, it's really in here, in this place where we are.
There's just 50 centimetres between the 30-ton fuselage section and the villagers' homes.
We are crazy.
While some enjoy the spectacle, others are not so happy at the disruption.
Voilà ce qu'on nous amène dans les vallées. On a été un petit village tranquille, voilà.
This is no one-off event. When the plane hits full production, these convoys will be passing through once a week. With Levignac successfully navigated, the last 11 miles are relatively easy. At last, after travelling by ship, barge and lorry, the lights of the final assembly line are in sight. Although it's nearly 3 o'clock in the morning, there are several hundred people waiting outside the massive new factory. Among them is Charles Champignon, here to witness a significant step forward. The delivery papers are signed, and now Charles and his team are ready to tackle the next phase of this enormous project.
For some people it's like a relief because they've delivered the final assembly line, they've done the factory, they've demonstrated the transport system. But for us guys, we are looking at the next steps: integration, first flight, then flight test phase, and then deliveries to the customers.
The work has only just begun. By May the 27th, 2004, the process of joining the plane together can begin inside the huge new factory. The plane's aerodynamic efficiency relies on it being accurately assembled, quite a task when dealing with such large parts. Supervising this difficult phase is Gilles Cormier.
We need to be very, very accurate. We have to be sure that the general the shape of the aircraft is in line with the specification, that the geometry of the aircraft is good, and to avoid twist fuselage or twist wings. And the performance of the aircraft depends on this shape.
Ensuring that the 3 body sections of this 73-metre giant are brought together in a perfectly straight line requires massive tools, the latest technology, and lots of patience.
I feel very confident now, even if it's difficult, because we have put in place a very accurate systems.
The key to success lies in the use of lasers. Invisible beams scan the sections of the fuselage, and the light is reflected by mirrors mounted on the approaching components. From these reflections, a computer can work out the exact relative positions of the parts, ensuring perfect alignment. Once positioned, the fuselage shells are brought together very, very slowly. Each turn on the dial brings the massive parts a millimetre closer together. On the left, a part made in Germany. On the right, one made in France. The last stage of their 1,200-mile journey. The clearance is so tight, metal shoehorns are needed to ease one shell over the other. But it's a perfect fit. The final joining together of an elaborate European jigsaw puzzle. Soon the sales team will have a real plane to show to their customers. But the question is, will the airlines like it?
Thank you.
It's now the 23rd of July 2004, and for Chief Commercial Officer John Leahy, the pressure is mounting. Leahy needs 250 firm orders for the project to break even. So far, he has 139. Today, Qantas Airways, who have ordered no less than 12 aircraft purely on the strength of Airbus's promises, are coming for a tour to see if they've spent their £1.8 billion wisely.
We're going to go out and greet them? Yeah. Okay. Well, where's Chris?
Is that time?
Are they going to get about a 10-minute warning or something on the bus? It has to go smoothly. But this is one of our best customers, one of our bigger customers now for the 380 program, and we want to make sure that they're happy, that they get the answers from us that they want, and they go away with a good impression. You can imagine what would happen if they came here and said, "Oh my heavens, the A380 isn't what we thought it would be." In front of their entire board, that could be devastating.
It's also an important day at the factory, as the first wing is about to be mounted. Despite the use of computer-aided design, teething troubles are inevitable with the prototype, and some minor work is needed on the fittings for the joint. Project leader Eddie Davis has to respond quickly to this kind of challenge.
It can happen with new aircraft. This is a last-minute job that we've had to come up today. We didn't know that the fittings weren't to the right standard, so now the guys are reworking them.
Once again, accuracy is vital. The slightest error in the angle at which the wing meets the fuselage could have a drastic effect on the handling of the plane, and critically, its fuel economy. With so many sales resting on the performance of this machine, it's a job that cannot be rushed.
C'est une phase où on va y arriver en une fois, quoi. Il faut y aller tout doucement, petit à petit, par les mouvements pour y arriver. Après, il y aura juste en position finale pour ajuster les angles de la voilure pour avoir le bon aérodynamique en vol. Les performances de l'avion dépendent de ce réglage, oui, tout à fait.
Again, the laser positioning system ensures the wing is in the right place and at the right angle. But after a whole day of careful work, another small problem appears. Some large bolts have been left attached to the wing.
We must remove this one for finish the junction of the wing.
A quick phone call to check that it's okay to remove them, and now the wing can be safely joined to the fuselage. A couple of miles away, at the perfectly manicured Airbus headquarters, John Leahy is conducting his guided tour for Qantas. They have arrived at the Airbus showroom, where they'll see a new, far more realistic interior.
Okay, now I think we've got just about everybody. Okay, now Rod.
Though it's all smiles, this is deadly serious. If they don't like it, there'll be trouble ahead.
It's almost like a young family introducing their new baby to the relatives. You want everybody to be impressed. You want everybody to say it's beautiful. And deep down inside, you're really waiting to see what they truly do say.
The head of the airline is Jeff Dixon, a tough-talking, no-nonsense businessman. To begin with, he doesn't seem too impressed.
Notice the headroom. This is coming out about standard size.
John presses on with the walkabout, and then, almost in a whisper, Jeff reveals his true feelings.
But just to give an idea of space that you've got. It's true. And that's the way the liners are.
Oh, it's fabulous. Better than we expected when we ordered, but we did expect a lot, so yeah, right up to expectations.
watch this. The idea
Although the mock-up gets a good reception, Airbus still have to prove they can deliver the airliners on time.
This is the same size.
With billions already spent on a plane that is yet to fly, there's a lot at stake.
The dimension of a 350.
Now, I wouldn't go as far as to say they bet the shop on it, but they've certainly bet a lot on it. But then, by the same token, we're not betting the shop on buying it, but we're making a huge commitment to an aircraft that hasn't flown. Now, we know and very confident that it will fly, and it will fly very, very well. But still, we're all making very, very big commitments and taking quite a few chances in a development like this.
If the planes are late, Qantas could demand significant compensation. There's not a moment to waste. By mid-June 2004, major structural assembly of the biggest airliner in history is well underway. This is the horizontal tailplane. With a span of 32 metres, it's as big as the wings of a small airliner. Made of carbon fibre in south and central Spain, it's easily the biggest tailplane ever made. The tail fin is another carbon fibre monster. 14 metres high, this component is made near Hamburg in Germany. When installed, it will stand as high as an 8-storey building. Some airports will have to buy new cranes to service it. Carefully, it's craned into place and attached with 24 titanium bolts. As the last piece is attached, Charles Champion comes to check on the plane, and Gilles Cormier has bad news for the boss.
Mais on a un problème de qualité avec ça, quoi. Alignement sur le cadre 110. Le vrai problème, il est là maintenant. Et pas bonne, quoi. Est à reprendre.
The last piece of fuselage, the Spanish-built tail cone, is out of line.
Non, c'est 6 mm de là à là. Donc oui.
6 millimetres might not seem very much, but the problem will take 3 days to sort out. Time they really don't have.
I think it's one of those phases when where the success of the project is at reach, but you have many elements to tackle in parallel in order to make it happen. So you're under control, but you've got to work fast on several parallel subjects in order to be able to deliver the project at the end.
The next stage is to install the landing gear. These substantial parts have to be extremely strong. Not only is the A380 the heaviest passenger plane ever built, its landing gear must be able to cope with extreme situations. Many landing gear engineers have a copy of this low-resolution video clip as a reminder of the conditions that can occur. Heading for the now disused Kai Tak Airport in Hong Kong is a Boeing 747. Approaching in a crosswind, the left-hand gear is about to take the full weight of the plane as it hits the tarmac. Amazingly, this was a successful landing, and the A380 will need gear that's stronger still. The 747's gear is made by Goodrich, who are also supplying the main gear for the A380. Here, near Toronto in Canada, production is well underway, and testing is just about to begin.
When we have a new landing gear program, we have a lot of tests that we need to do. Strength, performance, dynamics, durability. This one is a performance test. This is one of the first tests we do. It's one of the more important tests. It's called a drop test. What it is a simulation of landing. So when an aircraft lands, an A380 lands, got 560 tons of aircraft moving slowly towards the ground, as well as 200 miles an hour down the runway. When the aircraft hits the ground, something has got to absorb that energy. So if you jump off a chair and you land, your knees have to bend and give a little bit. even just with the weight of a person, you're going to damage yourself if nothing gives. So that giving of your knees, your legs are absorbing energy. That's what the landing gear has to do, but it has to do it for, instead of 180 pounds, it's got to do it for 560 tons.
Suspended inside this huge tower, the landing gear is raised in preparation for the drop. The rig is static, so to simulate the approaching ground speed, smaller wheels driven by powerful electric motors spin the big 55-inch tyres in the reverse direction. When a switch is flicked in the control room, a hook at the top of the tower will release, allowing the gear to fall. It must absorb the same energy as a 100-mile-an-hour car crash without being damaged. It's a critical phase in the whole programme.
This could be a make or break test. If the performance of the landing gear isn't what we predicted it to be, it could impact the schedule for the first flight. So it's essential that the gear performs to how we predicted it. And from these tests, we'll be able to tell whether it does.
Although it's huge, the size of the A380 means that this 6.5-ton component is just one part of the plane's undercarriage. In total, there will be 2 6-wheel units under the body, plus 2 4-wheel units under the wings, and a 2-wheeled set in the nose. So what you're about to see is only a fraction of the energy involved when the vast airliner touches down.
Okay, I'm going to drop now.
Go ahead.
Oh, too hot.
Just a delay, you can see it moving here.
Oh.
All right.
The test goes well. Early data shows that although there was an unwanted shudder as the wheels came to a halt, the landing gear shrugged off the huge impact with ease. It's now only 9 months to the first test flight. In Toulouse, the tail cone has finally been fixed, and the A380 is at last ready to move to the next stage of assembly. For Gilles Cormier, it's a relief.
Maybe we forget a little the trouble we encountered during the past weeks, and now we are looking at the aircraft itself, the achievement, more than the difficulties we had.
Now's the chance to see at last the biggest airliner ever built. With the shell of this aircraft complete, things are about to get really complicated. The plane is scheduled to spend the next few months in this vast hall, where thousands of parts will be fitted, including over 500 miles of wiring. The man in charge of this tricky phase is fully aware there's an awful lot of work to be done by the end of October.
It's a very difficult challenge, because it's a prototype. So it's very difficult to meet our deadline.
August is fast approaching, the traditional holiday month in France when most of the country shuts down. For Airbus engineers, this year there will be no holiday.
My family are very aware of this personal challenge. So everybody in the family is okay to say, okay, this year it's the aircraft year.
The plane is lifted on huge jacks, and teams of technicians begin work. The next milestone is when the aircraft will be revealed to the world, just 196 days from now. Attending will be VIPs, 5,000 guests and the world's media, with the pictures beamed by satellite all over the world. But for now, one 55-year-old man has a rather special interest in the new machine. Jacques Rosé will be the first person in the world to fly the plane. Seeing it for the first time, his reaction is not exactly what you'd expect.
Generally speaking, no, it's an aircraft. Larger than the one we have already, but I think I feel very, very confident.
He's confident because although the plane is still far from finished, he and his team have already spent thousands of hours flying it. These flight simulators hold the heart and soul of the new plane, already living and already being tested. The state-of-the-art computerized flight control system means that the plane can be made to handle almost any way the development team chooses.
You don't realize that you fly such a big aircraft. You fly it like you fly a little aircraft. It's incredible. It's very, very easy to fly, like a bicycle. It's a kind of large bicycle, if you like. I get.
The simulator is so advanced that today they are testing a scenario that is only like to occur once in over 1,000 years of flying.
3, 2, 1, now.
The wings are covered in ice, 2 of the engines have failed, and half of the flight computers have gone offline. Can the plane still be controlled?
Piece of cake.
Piece of cake.
Piece of cake.
The technology that makes the plane so safe is also extremely complex. And when battling against a deadline, complexity eats valuable time. The schedule is slipping.
Getting the airplane out on time is critically important. There are significant penalties that we would have to pay to each customer if we delay his aircraft after a certain grace period of, I don't want to say how long, but a certain grace period involved in every contract.
We can't relax. We can't relax. We have no right, we have no time to relax. So every hour, every minute we are there on the workshop, our main job is to receive pressure and to transmit pressure. And it's a nightmare. It's a nightmare.
5 to 6.
The penalties for late delivery run to hundreds of thousands of pounds a week. And that pressure runs down the chain of command, all the way to the men and women building the machine.
Some people could, how do you say, break down, no?
Christian Polite is the engineer in charge of the tail fin, known as the vertical tailplane or the VTP. Building this huge part has not gone smoothly, but finally it's time to install the last piece, a camera that gives the pilot a bird's eye view from the very top of the fin, some 23 meters up.
Right now we're going up to the almost to the very top of the vertical tailplane in order to install the last component which remains on the VTP still left. Yeah? You can easily see that this part is only screwed to the structure by, I guess, 20 screws around, and it has to be connected to the electric system via these 2 little connectors. The signals are transferred via a fiber optical cable down to a monitor in the cockpit.
Here at the Airbus factory in Stade, Germany, back in February 2004, Christian oversaw the final construction of the largest carbon fibre fin ever conceived. The ambitious scale of the production process meant there were always going to be problems.
We started with a schedule which allowed us to assemble the first fin within a reasonable time, but in fact we encountered problems which delayed the time for the assembly, and to worsen the situation, the lead time was shortened. So we ended up with a lead time that was nearly half of the original lead time we planned.
The fin was delivered on time, but it wasn't completely finished. Christian has had to move to France to continue the work.
We came here and thought we have a good planning, we have a good time schedule, we have everything on hand, but it wasn't like that. The moment we started working, we had to change each and every point. The planning was upside down, and so we had to start to work. So that's the way you can find the way through the jungle. Yeah.
Now though, as the screws go in on the camera, the end is in sight.
It's a good sound. That means the screw is in. With every screw we're a little step towards the end, yeah?
But then there's a problem.
Nee. Lass mal sehen, ja. Erstmal.
The fibre optic cable is too short to reach the camera.
Ja, da hast du nichts mehr. The connector is here, and the cable ends here, and we have to have another 1 centimeter, about half an inch, which is the cable too short. I mean, but these are, yeah, these moments really piss me off. I mean, when you're almost done, so close, you can see the end. You almost stepped over the line, and then someone blocks you, hits you in the face, saying, "Hey, you're not yet done. How could you imagine? Could you imagine?"
Despite the setbacks, the build must continue as fast as possible. Now they can begin mounting the engines, some of the most expensive parts of the whole aircraft. Together, 4 of these giant Rolls-Royce Trent 900s cost nearly £36 million, a quarter of the cost of the plane. Back in May 2004, the engine flew for the first time. It was bolted onto a much smaller airliner, dwarfing its other engines. Weighing over 6 tons, the Trent 900 can produce up to 35 tons of thrust at full power, burning a gallon of fuel every 4 seconds. These early tests proved the engine at altitude, but there's a much, much tougher test to come. Here in Hucknall, Nottinghamshire, a second test engine will soon be a smoking ruin, deliberately destroyed as part of a dramatic yet vital safety test. It's an important time for the entire project, and as engineer Hilary Barton travels to the test, she admits to some nerves.
I must admit, I've got a few butterflies at the moment, but basically everybody's done the preparation and it's just now a matter of getting on and doing the test. But obviously before the engine starts, you're sitting there just kind of hoping it all go well, but just really waiting for it to happen now.
Every few years, a fan blade will break in a jet engine somewhere in the world, a rare but violent event that must not put lives in danger. At the root of the coloured blade is an explosive charge. With the engine at full power, it will be detonated, releasing the blade with tremendous force. Whatever happens, no large debris can be allowed to burst out of the engine casing. If it did, it could do serious damage to the rest of the aircraft. From the safety of a room 200 metres away, watching on video, 25 key personnel are waiting. In the split second the blade is released, the casing must successfully contain an enormous impact.
It is a very violent test. This thing is spinning around, it's at full power, so you've got the forces on the blade are quite significant. It's like having a locomotive hanging on that blade. So you're actually having to contain the energy of that system. So there's a lot of energy involved in the design and containment of the blade.
The engine is run for 5 minutes, so final checks can be made. With such an expensive test, nothing can be allowed to go wrong. High-speed film cameras are used to analyse the action, and at last the throttles are opened and the engine brought to its full, awesome power. This is what it feels like to be inside a building 200 metres away from a £9 million blade-off event. Blade-off testing is normally top secret, but for the first time, Rolls-Royce have released this footage. Although the engine was totally destroyed, the fan case did its job, and no large lumps of metal were ejected.
Well, that was an expensive 5 minutes.
It was, wasn't it? I feel very relieved. Obviously, it's gone well. We've had a good test, and it's all credit to the guys. And yes, we've got a successful test under a belt. So I feel relieved and really pleased.
By December, the plane is finally about to leave the equipping hall in France. Airbus are trying everything to make back time, even if it means working over Christmas. With the grand unveiling just 5 weeks away, the next giant task is to paint the massive machine. In yet another vast hangar, working over the holidays, 90 painters descend on the plane. First, they rub down over 10,000 square metres of bodywork. Then, after applying a very large amount of brown paper, the A380 is ready for a brand new paint job. All in all, more than half a tonne of paint and primer are needed to protect the aluminium skin from the elements. The final livery has been a closely guarded secret until January the 18th, when the A380 goes public for the first time. The world's press are here, and as ever with this plane, it's a big deal. Inside part of the final assembly line, seating for 5,000 guests has been installed. In the equipping hall, now full of part-built planes, TV reporters are hard at work, feeding the story to the networks. Richard Branson has grabbed the headlines with news of double beds and casinos in his planes. For John Leahy and many others, it's a welcome moment of satisfaction.
It took an awful long time to get here, didn't it? But now we're here. It's pretty exciting.
The heads of state and governments arrive and take their places for a spectacle featuring dry ice, flying machines and computer graphics. Despite several high-profile speakers, there's only one star of this show. Finally, the biggest airliner of all time is there for all to see. for Charles Champion and everyone else who built the plane, it's a moment to savour.
Well, it's a good achievement, huh? I mean, a good show and good speeches and a nice aircraft. And tomorrow back to work to make it fly. No, it's good. It's good.
With the plane unfinished and with billions of pounds riding on its performance, the programme is about to enter the most critical phase yet. By March 2005, the Airbus A380 is being worked on at a feverish pace. The engineers simply have to get the plane finished and into the air.
It's like the final climb to the peak of Everest, let's say. The last sort of 10, 20 feet when the oxygen levels are so small is often the most difficult part of the journey, and that's essentially where we are at the moment in terms of this aircraft.
Simon Sanders is in charge of testing the deployment of the landing gear, a critical safety requirement. In just 56 days' time, the pilots' lives will depend on these 22 wheels, retracting and extending come what may.
Donc c'est parti, maintenant on va faire une rentrée du train.
Altogether, the gear weighs the same as 20 family cars and must be lifted into the belly of the plane in just 13 seconds. Getting the system operational has taken months of hard work, but now it looks as if they're finally making progress.
The last few months have been very frustrating because we've had obviously a lot of technical difficulties with systems on the aircraft. We've had a lot of problems during testing, so we've all been working very, very, very hard in order to have all of our systems all working for first flight.
Hey! Woo! So that's system one, looking good. This is why we're here. Days like today is why you do this job, because it's very exciting to see the gears moving, and you spend an awful lot of time making sure that the right parts are where they should be, and so I've been waiting for this for months.
Their last hurdle is to simulate a worst-case scenario. Even if all power was lost during flight, the pilots must still be able to lower the wheels to land. In such an emergency, the gear should fall down under its own weight. But testing it is risky because the wheels will hit the doors as they drop, and that could cause damage.
So this is the big test, yeah.
The outer doors begin to open under their own weight. Any second now, the locks that hold the gear up will release. Immediately it's clear that something has gone wrong. Next, the massive six-wheeled main gears deploy. And after a delay of 16 seconds, the jammed outer wheels slip free. It's not a good result.
We've worked as hard, we've done the best we possibly can, and we are where we are at the moment. For me, it's something to get stuck into, something to understand, something to find a solution.
Or do you want to do the normal cycle first?
The team suspect that the wheel might be sticking on a guide ramp, an aluminium plate where the wheel is supposed to push the door aside. Smearing it with grease should prove if this is quite literally the sticking point. The ramp does seem to be the problem. A permanent solution is needed, and fast. Finding answers to sticky problems is all part of the business. And over in Hamburg, Airbus have been straining to ensure another important system works perfectly. Laid out in this building is a full-size test rig of the waste system for the A380. With up to 20 toilets and around 900 metres of piping, it's a big job. Senel Myrtle and Dennis Kaiser have been hard at work for the last 2 years.
We will give you a short demonstration of a toilet flush on the A380. So at first we have to evacuate the toilet system. I can start this, it will get a little bit loud.
The toilets work by pumping air out of waste tanks in the rear of the plane, causing a partial vacuum. When a toilet is flushed, air is sucked in to fill the vacuum, and the waste is drawn down the pipes into the tanks. In the finished aircraft, these parts are made of titanium to save weight, but here Perspex is used for clarity. This is Formula One technology for toilets. And the result is some seriously speedy sewage.
The speed on the piping is around 60 meters per second.
60 meters a second is about 130 miles an hour. Such high-performance plumbing is needed because of the size of the plane. At nearly 73 meters long, the loos at the front are a very long way from the tanks at the rear.
This is the most forward toilet in the A380, the one what the pilots normally would use. It is quite difficult because you have a pressure loss from the waste tanks to this toilet because of the length.
It's a challenge not to be sniffed at, but undeterred the guys give it a go. Just seconds later, the waste arrives at the tank, and flushed with success, the engineers bring the A380 another step closer to reality. By March the 14th, 2005, the A380 is parked outside the factory here in France. The customers for this first plane are technically the test pilots who will fly it. But there's still a lot of work to be done before they will accept the machine. Head of the programme, Charles Champion, comes to take another look and discovers it's not all bad news.
That's the most important part. The coffee machine for the flight test crew. If this doesn't work, they will never take the aircraft.
Joking aside, it's clear that the plane is far from ready. The landing gear is just one of the things that need to be finished.
We still have a lot to do. There is a lot of activity, so some of it is related to troubleshooting and other related to closing the area, but we do have a lot of people still working on the aircraft.
The next day, the test pilots turn up for a photo shoot. The media are naturally interested in the 6 men who will fly the A380 for the first time. Although they pose happily for the cameras, it's clear where their real interest lies, for within minutes of the last shot being taken, they're in the plane checking out the new machine. For flight test director Fernando Alonso, it's important to feel comfortable at his post.
This is the place where I will be sitting for the first flight, and it'll be almost my home for the next months ahead. Yeah.
Surrounded by screens and readouts, Fernando will be able to monitor everything happening to the plane in real time.
This screen, for example, it's what we call the flight display. So it shows us the aircraft pitch attitude and bank angle. It shows us the speed, the angle of attack, the altitude, the heading. So just by having a glance at that screen, we have a very good overall picture of the airplane.
The aircraft is equipped with sophisticated flight instrumentation, thousands of sensors that record every aspect of the plane's performance. Gathering this precious data is vital to the test flight program.
If on the day of the first flight, the flight instrumentation does not work, we will not fly. So it's I think that sums it up, you know.
Despite the seriousness of the task ahead, there's no doubt that A380 is beginning to generate a real buzz.
It's really great to be here. We've been waiting for it so long, and now we're almost there.
March the 30th, and the plane is in a hangar again for final tests on the electrics and hydraulics. The moving surfaces are working, but one safety-critical system still remains unproven.
Okay, cheers.
Simon Sanders is back for a last-ditch attempt to show the landing gear will deploy properly. His team hope they've come up with a solution to the problem with the sticking wheels.
This is the ramp on the wing gear door where we put the grease last time. Now for a more robust solution, we've applied a layer of Teflon paint, which is similar to the Teflon, the coating that you have on non-stick frying pans. So this will reduce the friction when we do the freefall. We're going to now perform the test to demonstrate that with this low friction Teflon coating that we've solved the problem.
The man they have to convince is test flight engineer Gerard Dubois, who'll be sitting in the cockpit during the critical first flight. If Gerard is not happy, the first flight will be delayed.
I want to be sure on this aircraft, before taking the aircraft in the flight test department, that the landing gear is working perfectly well. If it doesn't work, I will refuse the aircraft until the system is completely safe.
As the landing gear is retracted in preparation for the test, everyone is aware they cannot afford to fail. In the cockpit, the system is primed.
C'est parti, je lance.
The problem persists, but at least the gear slips free sooner than last time. In flight, the airstream will probably shake the gear free sooner still. It's up to Gerard to decide if he's happy to accept the plane with the gear as it is.
It's not marvelous, but it is working, and at least even if the left landing gear is not extended at the same time as the right one, yes, I think I will accept it. Yes.
The team will continue to refine the system, but at least the plane can now be handed over to the test pilots. Fernando Alonso is taking the opportunity to look round the plane to check that nothing has been missed in the final push.
Like always, at the end, if there's a big rush, we'll get very excited. But at some point in time, you need to take a decision. Okay, now stop. It's over, and we take it over, because otherwise it will just go on forever and ever. So.
The plane has everything needed for the test to come, including these water tanks that will simulate the weight of hundreds of passengers. But in the rush to get ready, it appears that something's been overlooked. The cabin lights are not working.
Cabin illumination is switched off. So we have no possibility to switch the cabin illumination.
I need the lights.
The cabin lights
need to have them on.
to be on. We have been having handover meetings for the past 2 weeks. Yeah. Nobody ever said that the cabin lighting was not working. Nobody ever mentioned the limitations. Nothing was said about lighting. So now we put on the breakers. If something burns, it will burn.
With Fernando's words ringing in their ears, the engineers get to work, and in no time the lights are on. Immediately the mood changes, and the plane can be officially handed over.
J'ai la clé de l'avion.
Et moi la carte grise.
For Gerard Dubois, it's just like taking delivery of a new car.
L'avion contre la voiture. On a une tradition en France, par exemple, un concessionnaire livre une voiture à son client, en général, il offre simultanément un bouquet de fleurs pour sa femme. Aujourd'hui, on a un magnifique bouquet de fleurs accroché sous l'avion. Ce sont des fleurs qui ont été cueillies ici, autour de l'avion. Voilà, tradition respectée à la française.
The A380 is towed to the test flight department, leaving behind the factory where it was assembled. It's a journey of only a couple of miles, but it signifies the beginning of its new life as a flying test bed. Quite a crowd has turned out, and everyone wants to know how long it will be until the plane flies. Previous aircraft have taken about a fortnight, but Alonso won't be pinned down to a specific date just yet.
I really do not want to be under the pressure of saying it's 10 days or 2 weeks. I don't know. It'll be when it'll be. And nobody's keener and more eager to fly than we are. So I think you just have to rely that as soon as we feel that the airplane's ready, we will fly.
In their time, these guys have test flown everything from airliners to jet fighters, but this is their biggest challenge. On previous programmes, they have performed takeoffs with runways flooded with tons of water. They've deliberately scraped the fuselage along the ground during takeoffs, and they've flown aircraft to Siberia to test them at 50 degrees below zero. Plus, they've thrown passenger planes around the sky in the most extreme manoeuvres. It's a challenging but satisfying job.
It's something which is rather demanding. It asks you to be at your best level permanently, because you cannot cheat. You are really flying in real conditions, and it's something which is stimulating, I would say.
Within the next 12 months, Jacques and his team will be pulling manoeuvres like this in the A380. But all that depends on getting the plane into the air. The first step is to get used to the aircraft, to make sure that they are familiar with all the systems and that everything is working.
C'est un couple d'air, ça. Ah ouais, les cendriers, oui. Non, mais les cendriers, il n'y a plus de raison d'en conserver. Bah, c'est les chewing-gums. La tabagie est en voie de disparition. Pour ceux qui bouffent des chewing-gums, il faut bien qu'ils puissent les coller. Sinon, ils vont les coller sous les FCU.
On y va là ou pas?
Oui. On peut y aller?
Tu peux refaire un coup de freinage sans parking brake si ça ne dérange pas.
Là, j'ai pas de parking brake.
Alors, tu relâches les pédales. Voilà.
C'est normal de 300 degrés, c'est bon. Brake saute. Ouais, ça marche.
By April the 8th, the team are ready to test the engines.
To start the engines, there's one ignition, which is that one for the APU. That'll start engine number 1. That'll start engine number 2. That will start engine number 3. And that'll start engine number 4.
With emergency crews on standby, the A380 can at last start to come to life.
Le sol pour le 2. Prêt pour le 2. 2, 1, top. Main ouverte.
The smoke is caused by a protective layer of oil burning off as the engines are run one by one. Testing and monitoring the engines takes 2 long days, but now the aircraft can move under its own power for the first time. The next 10 days are spent on further detailed checks on the ground, and the A380 becomes a familiar sight at Toulouse International Airport, taxiing up and down. Gradually, the speed is increased, and most importantly, the brakes are tested. By the look of the tyres after the tests, the brakes are well up to the job. Confident in the aircraft, is growing every day.
There's still some little things to be fixed, but we're getting closer. Every day we're closer.
Each of the flight test team has a very specific job. And flight test engineer Jacques Joie's role is to monitor the engines. On the way back from one of the ground runs, Jackie thinks he may have spotted a serious problem.
I saw it while we were taxiing back from the,
you saw it
from
go
the
in?
inside. Yeah. No, I saw that there was a white spot that looked suspicious.
Okay.
He suspects that something has gone into the engine, and there's a fear that whatever caused these white marks has damaged the 6-ton, £9 million power plant. Replacing the engine would almost certainly delay the first flight. Gérard Desbois arrives to give his expert opinion.
Non, c'est uniquement de la craie.
C'est du caca d'oiseau.
Tu déconnes. Ouais. C'est ça? Fais sortir.
It is a bird shit.
Tu déconnes.
Ah bah tiens, arrêtez.
Et arrête.
C'est du Kafka.
Là, il a raison. It's bird shit.
If that's the bird shit, where did the bird go? He was scared. He was really scared. Really scared.
Là?
2 days later comes a stark reminder of the dangers facing the test team. Jim Fawcett has to make sure they are familiar with all the safety kit on board, including an emergency escape chute should the unthinkable happen.
So, we have an emergency evacuation system. This is fired by pyrotechnic handles in the cockpit and in the flight test engineers station. They drive a firing door which is down the bottom of this tube here in the main cargo door. The crew can come and jump safely out through this door and with the aid of a parachute get down safely to the ground.
Allez, c'est parti.
After 2 weeks of hard work, there's one final test. The engines are brought to full power for the first time. Accelerating hard, the plane reaches 130 knots, almost 150 miles an hour.
110. La VR est bonne. 120. 130.
And the brakes are applied.
Reverse de verte. Pas mal la reverse. C'est bien, c'est bien. Et les spoilers, c'est bon.
With that, the world's biggest airliner is ready to go.
Relâche les freins. 70. Reverse idle. Je relâche les freins. 60. Pas mal. Pas mal, pas mal. C'est bon tout ça, ça. Bon, ouais, engine 1 and 2 minor fault. Ouais, comme d'hab. Ouais. Pas d'alarme en temps. Bon. Ouais, ça va. Impeccable. Impeccable. Bon. Ouais, ça va. Impeccable. Impeccable.
The day of the first flight of the A380 has arrived.
I just hope the day goes by very, very, very slowly. I want to profit every single second of it. So I just want things to happen very, very slowly.
Now you think of what you're gonna have to do, so it keeps your mind busy. It's difficult to sleep properly, but it's a special day. You can do without the extra hours of sleep. I will catch up tonight.
Over 50,000 people have come to watch.
It's the largest airplane in the world, and it's going to stay the largest for a couple of years, I guess.
It's amazing what they have achieved with this aircraft. You have to imagine that there are nearly 600 people on board of that kind of aircraft, and that's really amazing. They can be proud of it.
This is what it's all about. Whether you're an aviation or an engineering enthusiast or not, this is still a very significant day.
today is really the day for the A380 and all of us who have worked on it. So we're all having our fingers crossed to be sure everything goes well. But afterwards, I think there's going to be quite a few fiestas tonight. I tell you.
The first flight will last about 4 hours, and as the pilots make their way to the plane, all around the airport preparations are being made. In a building 500 metres away, dozens of engineers are gathered in the control room, where they will be able to analyse live data sent from the aircraft. A light jet will act as a chase plane, able to watch the A380 from the air and report any problems. Hundreds of journalists are waiting to relay the story to the world. The crew must wear full safety equipment for the first flights: life jackets, parachutes and helmets. And they're strapped in tight.
Jackie, oui. On peut faire descendre les gens? Oui, d'accord. Il n'y a plus besoin? Bon, Gérard, ils sont d'accord derrière. On va fermer les portes. On va fermer les... We shut the door.
The engines are started and the aircraft pushed back. On the far side of the runway, Christian Polite, whose team fitted the tailplane, is just one of thousands who have worked so hard to get to this point.
In the last seconds before takeoff, I mean, I don't think that I will think anything about it. Just cross the fingers and get it off the ground, yeah?
At 10:18, the plane is lined up on the runway. While the world waits with bated breath, inside the plane, the only problem seems to be the strap on Fernando's helmet.
Jackie, oui. Tu peux m'accrocher ça, j'arrive pas.
Oui, ça va être ça. Regarde, attends, je vais me lever. Il lève sous main. Je vais donner un coup de poing. Hein. Ouais. T'as rien à faire.
Messieurs arrivent.
Ils en sont au coup de poing?
Oui. Ça devient grave là.
Non, la putain de poing.
C'est le bouton pressant.
Je te redonne un coup de poing, fais gaffe. Ça fait mal?
Non.
Non. Non. Là, il y est.
Là, c'est bon.
J'ai
survécu. Bon, messieurs, le point 3 est fini. Le skip shoot est armé chez moi.
Chez nous aussi.
D'accord. Allons-y.
At 10:29 and 32 seconds, the throttles are opened.
Les dots.
Here we go.
Poussez. 100% partout. C'est bon.
That was effortless.
Excellent demonstration altogether. And it was really like a diamond in the sky, stable and moving away. Really nice, really nice.
13. 179. C'est bon. Parfaitement équilibré.
The next few hours will be spent gently probing the aircraft's abilities. And 15 minutes in, it's time to retract the landing gear.
Allez.
Bon, milestone numéro 1, messieurs.
Alors là,
c'est là que les
allez, vas-y.
3, 2, 1, top. Alors, les portes s'ouvrent du body. Tout est nominal. Je vois les bodies rentrer, les wings rentrer. Les bodies sont ouvertes encore, les portes. Top, les bodies se ferment. Le train est rentré.
The flight is a remarkable demonstration of modern aviation technology.
C'était un vrai plaisir, hein. Ouais, vraiment comme au simu.
After years of effort, the men and women of Airbus can at last say that they have built the largest airliner the world has ever seen.
Les spoilers sont sortis.
The future of air travel is explored further on our Building the Best website at channel4.com/science. What Big Brother is next on 4 is Max falling in love with Saskia. That's what Derek suspects. The diary room heart to heart coming up.